Hello everyone, my name is Sha256 and this is my channel Pentest Diaries. Today I'll make another video on the same series of Solidity programming series, and in this video I'll try to cover a cryptographic hash function. So I'll try to cover three cryptographic hash function. One is Keccak256, Sha256 or Ripemd160. These are the three hash function. I'm using it over here itself just to demonstrate you how exactly we can utilize it. We'll start with the theory part first and then we'll go to the practical section. Not much practical stuff is getting covered in this video itself, but theory part is most important, and you just should be aware about it at the time of writing a smart contract and efficient smart contract for it. So we'll start with the theory part first. In Solidity programming language commonly used for writing a smart contract on the Ethereum blockchain, you can use cryptographic hash function like Keccak256, Sha256 and Ripemd160. These functions are typically used for various purposes, including creating unique identifier, verifying data integrity, and generating hash-based signatures. So if I'm talking about the Keccak itself, 256, though this is a hashing function used in Ethereum, you can use it by simply calling a keyword which you call it as a Keccak256. Now if I'm talking about the Sha256, Solidity does not have a built-in Sha256 function, but you can easily integrate it using libraries or by leveraging external contracts that provide this functionality. So just remember it like Sha256, there is nothing like a functionality inbuilt we have it in Solidity, but you can integrate that using external contracts itself inside of the Solidity. Now talking about the Ripemd160, so similar to the Sha256, there is no built-in Ripemd160 function in Solidity, so that was the reason we don't have any keyword over there itself. But you can use external libraries or contracts that provide this functionality. So we can use external contract to provide this functionality, what exactly we are looking for it. Now remember to be conscious when dealing with the cryptographic operations and smart contract, as improper uses can lead to vulnerabilities. So definitely if you're not making it configure appropriately for it and using improper cryptographic hash at improper page, like take example, you have different type of requirement over there itself and you're using different type of hash over there itself, then you make your smart contract vulnerable. So make sure that you have to analyze it appropriately and accordingly take the action on it. Always review and test thoroughly and consider using well audited libraries for cryptographic operations. So make sure that when you're utilizing any cryptographic libraries, make sure it should be properly audited appropriately before going further with the production setup for it. So when you're making any smart contract, make sure these things to be review it first before going further with the final stage of the production. Now if I'm talking about the three category for it, Keccak256, Sha256 and Ripemd160. Starting with the Keccak256, it take an input as a bytes and give output as hash of 32 bytes. It's both it's a bytes only, so I'm taking my word back, it's not bit, it's bytes. Sha256, it take an input as bytes and give output as a SHA of 32 bytes. Ripemd160, it take an input as bytes and giving an output as a hash of 20 bytes only. So that's exactly be a differences inside of it. Mainly we use a Keccak256 and the Sha256 only in a Solidity programming. And hash function is used for unique ID and contract sign itself. That's also one of the thing. So unique ID, wheresoever is a requirement of appropriate unique ID to be get utilized, over there only we have to utilize it, or we want that to be get hidden. So in that case only we are using a hash function over there just to make it a unique. We don't want to be get it copied anywhere else itself. That's one of the thing. Other than that, a contract sign, the time of the contract signing the contract itself, at that time also we require the hash functions. These are the two functions where we use it. Actually we are using a hash function. Now hash collision this is also one of the concept for it, and it's very interesting. If same hash values generated by two different input values, so we are giving two different input values but we are generating a same output, then in that case we are in a condition of hash collision. Proceeding further, we have two inbuilt function. One is ABI encode and another one is ABI encode packed. So we are using it also in our code itself. So I think we have done with the theory part, and I'm proceeding further with the practical section for it. And before proceeding further with that, I think like you are able to understand that how much important the cryptographic hash is inside of a smart contract itself, and bit it required in most of the cases itself when you go proceeding further for actual smart contracts where we wanted a payments and everything will be get integrated, and our main banking application will get integrated. At that time we required such type of thing to be get it appropriate cryptographic hashes to be get it utilized, cryptographic functions to be get it utilized over there itself, so that we make our application bit secure. Okay, so now proceeding further with our practical section, and then we'll just check like how exactly we can utilize that. So proceeding further with a practical portion itself. So this is code I have prepared for it, and in this is a straightforward syntax which we are using it, and other than that the contract name is hash. Now we are using three functions inside of it. The first function, which we call it as a hash, Keccak256. Over here itself, three parameters we are trying to pass it from our side. One as an unsigned integer, another one is a string memory, where we are giving a name itself, whatever the name we just want to give it, and this is just the input. And now the last one, third one, we call it as the address itself. We make this as a public. Then we talking about the pure, this is make a pure itself. Return, we are returning something, and which we call it as a byte 32, as we have already discussed in the theory section itself. In case of Keccak256, we are getting the output as 32 bytes itself. So that was one thing. I'm a bit confused about bits and byte itself over here. There was a couple of time I'm using bit, so it's not bit, it's a bytes only. Now in the return function itself, which we are seeing over here, so in the return we are just defining it that as a Keccak256. Now inside of it we are using ABI.encoded packed itself, which I have told you about it. There are two I can say that inbuilt function we have it inside of it. So that was the reason ABI.encoded packed. We have to define it all three sections for it, which we are returning a value for it, and the output, whatever the output over here itself, that to be get it encoded, and that we get the output appropriately for that, which in 32 bytes about the Keccak256. Okay, now this is a especially I can say that this is a function itself which is already be integrated over here in the Solidity itself, which we are using it directly instead of going with a longer process for the cryptographic hash and get that output. We are using directly that function which is already available. Now inside of the hash Sha256 itself, the same syntax we are using it, simply changing a name and returning a value like 256, and then we are encoding the output. Similar like that in case of another one which you're talking about, the Ripemd160, the same input we are giving it from our side, and now we are getting the output using that same function, inbuilt function we have it inside of it, with putting a 3 values and getting that output. Okay, in both the cases of Sha256 and Keccak256, we are getting a bytes 32 bit, but in case of the last one, Ripemd160, we are getting a bytes only 20. Okay, that was the output. So output is different for one, and output is similar for both. Okay, so now we'll compile the code and see the output for it. So let me deploy this. Once we'll deploy it, these are the thing we are getting it over here itself. We'll simply have to put the input from our side. So I'll put 1, which we are looking for it as an integer. Okay, now I'll give the name as Sam. I'll give it a address. I'm taking the address of the same through which we have deployed this smart contract. Let me put the address. Let me copy this. I'll click on the hash Keccak256. I get the output as byte 32. Now I'll put the same input in case of Ripemd160. I'm getting this output, and this is 20 bytes. I'm getting it, and now in the last one I put the same input and I'm getting Sha256. This is the output in 32 bits itself. You can see in all the hash function itself we are getting different output itself. That exactly the thing as per need itself, we are utilizing it as per our need wheresoever. You just have to check like what are the actual difference between. You just have to try to figure out with either with exploring over here itself or with a Solidity document sheet, try to get explore on the basis of what your requirement you have to utilize that. Okay, so that is the concept which I just want to get it covered in this video. I hope you like this video. If you like this video, please subscribe my channel, provide your feedback in the comment section of this video, and if you like this channel itself, please comment the things on it. I just wanted to know about it, if the things going well or not. This is almost be a 30th video I have prepared for this series itself, and I'll try a few more things to get it added in this series. Then I'll conclude this series and going further with another section for it. So I hope you like this video. Thank you so much once again. Take care. Bye bye.